All right, so start walking me through this. What's the first thing I need to do to solve this problem? Circle the angle. So we're going to circle the 51-degree angle. This is where we're going to stand to label our sides. And then which side do we label first? Hypotenuse. Where's the hypotenuse in the picture? Opposite the right angle. So it's this one over here. And then we label which side? Opposite. Where's the opposite side? W. And finally, the adjacent side. So that would be this 25 down here because that's the only side left. All right. So then we're going to bring out SOHCAHTOA. Sine, cosine, or tangent for this? Tangent. Opposite and adjacent, we do not have the hypotenuse, so we have to use tangent. Tangent of what? Tangent of 51 degrees. So this is where our angle goes. Tangent of 51 degrees equals what? W over 25. And now what do? Multiply both sides by 25. So into my calculator, we're going to do 25 tangent of 51. And what do you get for W when you do that? 30.872. Or 30.9 if you round to the nearest tenth. Do we need units with that? Feet. Very nice work on the warm-up. Very good job. All right, let's hop into your notes and finish those up. Today should be our last day in your notes packet. And then tomorrow and Monday we'll review for your test with the test on Tuesday next week. We were down at the very bottom of the front side of the last piece of paper. So what would be page 7, we're down at the very, very bottom, looking at problem number 3. It says, from the top of a vertical cliff 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? So we're going to start drawing this picture out. Thank you. So here's the cliff. And how tall is that cliff again? I'm sorry, one more time. 40 meters, thank you. It says the angle of depression. So I talked yesterday quite a bit about angles of elevation and angles of depression, but the big thing that I want you guys to remember about these angles is that they must have a horizontal side. Have to have a horizontal side. So an angle of depression is going to go from here and then angle down like this. It says we are at the top of the cliff. So from right up here, so this is my horizontal. We're going to angle down from here. And how many degrees is this? 34 degrees. The cliff and the ground should be making a right angle. And there's some kind of an object over here. We want to know how far the object is from the base of the cliff. So what are we trying to find in the picture? Where should I put the X? Here or here? On the bottom, where the base would be, bottom and base. Right, so X right here, this is what we're looking for. So I have this triangle, but my 34 degrees is not inside the triangle. The 34 degrees is outside the triangle. Does anybody remember? You can look at the top of the page to cheat. This 34-degree angle is exactly the same as which other angle in the picture? The angle that is to the right of the right angle. So over here by the object. This angle here will be congruent to this angle right down here because they are alternate interior angles. So this one down here is also 34 degrees. Now I have a side and an angle inside my triangle, and I have a side of the triangle that I'm looking for, so I am ready to label up my sides. We are going to stand down here where the object is. So I'm going to circle my angle. Then we label the hypotenuse. Across from the right angle is my hypotenuse. 40 meters would be which side? That is the opposite side. And so what we're looking for, X, would be the adjacent side. Sine, cosine, or tangent for this? Tangent. So tangent of 34 degrees is equal to, how would I set up my proportion, my fraction? 40 over X. Opposite over adjacent. Then I know we need to multiply. What are we going to multiply by? X, because it's in our denominator. We always multiply by whatever's on the bottom of that fraction. So X times the tangent of 34 degrees is equal to 40. I still don't have X by itself. I need X all alone on one side. How can I do that? We're going to divide. What are we dividing by? Tangent of 34 degrees. It's the thing next to X, and I want the X alone, so the thing next to it has to go. So now into my calculator, we do 40 divided by the tangent of 34 degrees. And that gives us what? 59 point, if I take it out to 3 decimal places, I think it's 302, right? Do we need units with that? Meters. Nicely done. Why? I'm not understanding where you're talking about. Which line in the problem? This right here? Why aren't we multiplying by this? Because over here it's being multiplied, and we want that to go away. I need to cancel out that multiplication. And division is the operation that'll cancel out or undo multiplication. So that's why we divide instead of multiply there. Good question. All right. Let's flip it over to the back page. Got 4 more problems, and then we are done. An airplane takes off 200 yards in front of a 60-foot building. At what angle of elevation must the plane take off in order to avoid crashing into the building? Assume the airplane flies in a straight line and the angle of elevation remains constant until the plane flies over the building. All right, so I'm going to draw my little airplane here. My art is not that great. All right, so there's my horrible looking little airplane. And here's the building. And then there's this space in between the airplane and the building. Do we know how big that is, the distance between the airplane and the building along the ground? 200 yards. And the building itself is how tall? 60 feet. We have a little bit of a problem here. When we're doing these problems, and I've asked you about whether or not we need units with that, we always figure out what units to use based on the other units in the problem, because they're always consistent. Do I have consistent units between these two? No, I have to make them the same units. Does anybody happen to know how big 1 yard is? 3 feet. So to figure out 200 yards in feet, we're going to times this by 3. And so it would be how many feet? 600 feet. This is what we're going to use for that side so that we have the same units as the height of the building. We need to figure out the angle of elevation that the plane is going to take off at. So right here, we're looking for this angle so that they don't hit the building. If it's a well-constructed building, the building and the ground should be making a right angle with each other. So now we're ready to label our sides. My hypotenuse is the path that the airplane is going to travel. Which piece is the opposite side? The building. So this 60 feet here is the opposite side. This 600 feet, because remember, we can't use the 200 yards. We can't have two different units. 600 feet is my adjacent side. All right, SOHCAHTOA. Which one do we need to use for this problem? Tangent again. We don't have the hypotenuse. Anytime we don't have the hypotenuse, it's going to have to be tangent. So tangent of what? Theta. Anytime they ask me for an angle, I'm going to put theta in that spot. So tangent of theta equals what over what? 60 over 600. I want the theta all by itself. What do I need to do so that I can get the theta by itself and the tangent to the opposite side? Absolutely correct. We move tangent over to the right without the theta, and we make it the inverse. That's how we get tangent to the opposite side. And then inside parentheses, we're going to put our fraction, 60 over 600. And now I'm ready to put this into my calculator. Theta comes out to be what? 5.710. Does that need units with it? Degrees. Nicely done. I want you guys to try number 5. I'm going to give you about, let's take about 2.5 minutes to do number 5. All right, I'm going to start off with a picture here. I'm going to try drawing a different kind of tree. I drew a Christmas tree last time, but here we go. So there's my tree. It says at a point on the ground 50 feet from the foot of a tree. So out like this. The angle of elevation to the top of the tree is 53 degrees. So what would that look like if it says the angle of elevation to the top of the tree? What do I need to draw next? Line that's going diagonally upwards towards the top of the tree. Something like this right here. And where would the angle of elevation go in that picture now? This little bit right here. Remember, angle of elevation has to have a horizontal component, so it has to have a piece to it that's like this. It does not have a vertical part, so it's not going to be this piece over here at the top of the tree, because that's up and down and then diagonal. I need one that is flat across the ground and then diagonal. So my angle of elevation, 53 degrees, goes right here. We know that it's 50 feet horizontally along the ground. And we want to use this information to find what? Find the height of the tree. So I'm going to draw from the top right down through the middle of the trunk of the tree. And we're going to call that X. Should be forming a right angle here, the tree with the ground if it's growing straight and tall. Then we label our sides. We don't have any information about the hypotenuse. Which piece is the opposite side? The tree itself is the opposite side. So this piece that I have marked as X that we're going to find, that is the height of the tree. So there's my opposite side. And so 50 down at the bottom is my adjacent side. And that means one more time we use which one? Tangent. Tangent of what? 53 equals X over 50. And so then we do what? Yes, we're going to multiply both sides by 50. And then we can pop it into our calculators. 50 times the tangent of 53. 66.352. And I'm sorry, what did you say the units were? Feet. Very nicely done. All right. Let's look at number 6 together. From the top of a lighthouse, 210 feet high, so I'm going to stop and draw that. I don't really know what lighthouses look like. So there's my lighthouse. It says the lighthouse is 210 feet high. The angle of depression of a boat is 27 degrees. So the lighthouse is on the edge of the water. There's a boat in the water. My artwork makes my 7-year-old look like a master. It says the angle of depression of the boat. What kind of a line do we have to have if we're doing an angle of depression or an angle of elevation? Horizontal line. And we are up at the top of the lighthouse. So here's my horizontal line. And then my angle of depression comes down as we look at that boat. So it's like somebody is standing at the top of that lighthouse. First, they're looking straight out ahead, and then they lower their eyes down to the water to see that boat. The amount that they lower their eyes down is that angle of depression. So that is 27 degrees. So what other angle would be 27 degrees? The other corner down by the boat right here. Anytime we have an angle of depression, the other side of it would be the angle of elevation, and it's going to be the exact same amount. So basically, if somebody at the top of the lighthouse has to lower their eyes 27 degrees to see the boat, the person in the boat would have to raise their eyes 27 degrees to see the top of the lighthouse. And then what is it that we want to find in this picture? How far the boat is from the lighthouse. So we're looking for this right here. Do we have the hypotenuse? No, that's this piece over here. Do we have the opposite side? Yes. Which one is the opposite side, the 210 or the x? 210 is our opposite side. And so x is my adjacent side. And that means one more time we're going to use tangent. Tangent of 27 degrees is equal to what? 210 over x. X is part of a fraction, and I know what operation will get it out of a fraction. Multiplication. Am I multiplying by 210? By x, because we always multiply by the bottom of the fraction, so it cancels my denominator out here. So I have x times the tangent of 27 degrees equals 210. And now we're going to divide. What are we dividing by? Tangent of 27 degrees, always by whatever is next to the x. I want the x all by itself, and since it's multiplication by the x, division will make it cancel. And now we can pop this into our calculators. And the boat is about how far away? Absolutely correct, 412.148 feet. There is one last problem here in the notes. I would like you guys to try number 7 on your own. I'm going to give you about 2 minutes again, and then we will go through that together. When I go to draw my picture, I know a wall looks like this. A wall is going to go here vertically. Which of these other two pieces is the ramp? Is it the flat part at the bottom or the slanted piece? It's the slanted piece. So here's our ramp. How big's that ramp? 5 feet. They're using the biggest one that they've got. The wall was how big? 2 feet. And we want to know the angle of elevation. Where would that go in the picture? Bottom right. So this is where we're going to put the theta, because that's the angle that we're looking for. Are we using tangent again? No, finally we get a break from tangent. So where is the hypotenuse in this picture then? 5 feet. The ramp is our hypotenuse. And the wall would be which side? Wall would be the opposite side. This bottom part down here that we don't have any information about is my adjacent side. So opposite and hypotenuse is what we have, which means which function? Sine, cosine, or tangent? Sine. Sine uses opposite and hypotenuse. Cosine uses adjacent and hypotenuse, and we don't know the adjacent side. Same problem with tangent. Tangent uses opposite and adjacent, and we don't have the adjacent side. So it's going to be sine of our angle theta is equal to opposite over hypotenuse. So what over what? 2 over 5. Now how do I get theta by itself? Inverse. Yep. Sine goes to the opposite side and it becomes the inverse. Theta stays on the left though. So inverse sine of 2 divided by 5. And what does that give us when we put it in the calculator? 23.578. And we put degrees with that. Very nicely done. You use tangent. There is one other piece that I wanted to talk to you guys about. If you'll pull your homework out, I just wanted to talk about one small thing there. Just so we're aware of it, because it could be a sticking point, but it doesn't need to be. So pull your homework out. I want to look at some of the ones where the picture is drawn for you already. So let's look at this together as soon as mine loads. Here we go. So number 5 is a good example. Number 5, they have the picture drawn for you already. I see the bottom down here between G and F is 122 feet, so that side of the triangle would be 122. But I noticed something interesting over here where the building is. There's 2 different numbers. Why do you think that is? Lucy is standing on top of it. So the building itself is 80 feet, but then Lucy is 5.5 feet tall, and she's standing on top of the building. So this entire side over here from L to G would be how big? 85.5. You have to add those 2 together to get that side of the triangle. There's another one that's similar to that on the back side. I believe somebody is sitting on a dock. It tells you how high off the water the dock is, and then how tall that person is when they're sitting on it. You have to put those together to get that side of the triangle to finish that problem. So make sure that you add those pieces together before you try to do your sine, cosine, and tangent there. Right? Very nice work today. Homework is due tomorrow. If you need another copy of the homework, it's right down here in this red organizer on the very bottom. You guys have about 10 minutes that you could work on that in class right now. Let me know if you have any questions. There are 8 problems total, so this is probably one of our shorter homeworks.